Good morning, everyone. Dear partners, dear participants, it has been a pleasure to recognize a huge registration to this final conference of the Sparkle project. And I have to say welcome and thank you to all of you, ladies and gentlemen. The Sparkle project has been a fundamental opportunity to make order and clearance on a common widespread scenario, often chaotic and poor comprised, as that is that of high technology and digitalization for sustainable agriculture. In particular, the sustainable agriculture oriented on sustainability and no less on profitability for the new entrepreneurship on farm management. The Sparkle approach avails itself of co-working and co-design and trust between all the partners with their own experience and skills. It has generated in the partnership an innovative vision and a strong impulse to adopt a new holistic vision in presenting high technology and digitalization oriented to the goal to choose and to effectively and profitably adopt innovation. Not without hard and difficult moment and discussion, we recognize the complexity of the topic and the different aspects in which are expressed the huge universe of technological and procedural proposals. But the experience and of the entrepreneurs, of the service company, and of the researchers involved in the partnership brought about the objectives of the course on the entrepreneurship for sustainable precision agriculture to address the fundamental question for the correct introduction of innovation. Why? With which technology? For which added value? In which context? With which managerial tools? This approach is an innovation also for we teachers at the higher school and university school. Why? With technologies, for which added value, in which context, with which managerial tools. All our university courses on precision agriculture have changed the approach in presenting technology to our students, to the future technicians, consultants, and entrepreneurs. And this has been a choral convincement that moves the focal point from technologies and procedures to the entrepreneurial and societal needs that can avail of this innovation. The 4 areas, declined into 12 lessons and 52 units of the learning course, represent a path of analysis acknowledged that cover the reference framework for the proper use of innovation on sustainable precision agriculture. But this will be explained in the specific speech of this final conference. I have to thank all my colleagues, in particular Stefania and Valentina, that bring the project in this path of 3 years. The designer and the manager of the initial proposal, Alessandro, and in a big hug, all the partnership for the exciting, even if sometimes tiring, achieved result. Thank you. Thank you to all of you. A great thank to the invited speaker. Thank you very much for their availability and high role in the agriculture and rural innovation. Thank you very much for your time given to us, and welcome to all of you attending this event. You're welcome.
Thank you very much, Marco, for the kind words, and welcome to everybody to this first session of the Sparkle Conference. I want to thank the partnership for giving me the possibility of being the chair of this session, and it is a pleasure for me to give the floor now to Miss Corinne Levesque, which is the project officer for the Sparkle project at EAKIA. So I will give immediately her the floor for some words as welcome. Madame Levesque, the floor is yours.
Yes, can you hear me?
Perfectly.
Okay. So thank you very much, Alessandro. I would like to start like this. Caro professor Vieri, prima di tutto vorrei ringraziarla e anche l'Università degli Studi di Firenze per il vostro invito. So I would like to thank Professor Marco Vieri and the University of Studies of Florence for their invitation. It is an honor to participate to this final conference. I would also like to thank the other universities and the companies that have cooperated on the project Sparkle, and to congratulate them for the work accomplished in this context. One of the project's strengths has clearly been through cooperation between academia and business and cross-national exchanges to enable project participants in Portugal, Spain, Italy, and Greece to benefit from the knowledge on the advanced technology now emerging in the agriculture sector. Moreover, it seems that for some of the participants, Sparkle has been an opportunity to experience cooperation with people and organizations located in other countries in the framework of a European project. And we hope that this was a valuable experience. In the course of project implementation, the members of the consortium have made an in-depth exploration of differences in traditions and attitudes in agriculture, and have produced valuable material for the design and development of teaching and learning in the field. Academics from different educational institutions and with different research motivations have discussed, shared their competences, and together developed new knowledge. Not only that, but partners have now a shared vision of precision agriculture, which is a new way of thinking. All these activities are not only important for boosting modernization in the sector, but also for pursuing a lower environmental impact, which is a key priority of the Commission. I would like to take this opportunity to also thank Mr. Vieri for his coordination of the Sparkle project. The project has been well coordinated with a good emphasis on consultation and communication within the project and a commitment to high quality. This was not easy, especially in the context of the COVID-19 pandemic. However, together you found ways to continue project implementation despite the current difficulties. I will finish these few words by wishing you a fruitful conference. Grazie mille. Thank you very much.
Thank you very much, Corinne, for your welcome. And now we can start the presentation of this first session of the Sparkle meeting. As you know from the agenda, the Sparkle final meeting is organized in 4 different sessions. The first 2 this morning, the other 2 tomorrow morning. The main topic that will be discussed during this first session is sustainable precision agriculture and education. So we will focus on the educational aspects of the Sparkle project, and we will try to give a general overview on the topic. That's why the first presentation will be given by an external expert, an external invitee from the Sparkle project. So it is my pleasure to give the floor to Ms. Simona Cristiano, who is a researcher for CREA, which is the Council for Agricultural Research and Economics. She will give a speech with the title "Training System in Support of Precision Agriculture."
Good morning, everybody. I'm Simona Cristiano. I work as a researcher at CREA, which is the Council of Agricultural Research and Economics. The center, particularly, I work for the Center of Policies and Bioeconomy. And today I'm representing somehow the Ministry of Agriculture because Pasquale Falzarano, who is in charge of this activity for the ministry, unfortunately couldn't participate today. So I bring to the greetings of Pasquale Falzarano, and I will do this presentation on behalf of him. Today we'll talk with you about, I will explain you the path we are conducting together with the Ministry of Agriculture. As CREA, we support the Ministry of Agriculture in this path in developing a national strategy for the digitalization in agriculture. So I will explain you more in particular, which is the current situation we are dealing with in developing these strategies, with particularly stressing our focus, which is on advisory and training system in support of the digitalization in agriculture. So particularly what we are doing, you probably know that since 2015 and until 2017, the Ministry of Agriculture set up a group of experts on digitalization in agriculture, who came out with a guidelines on the state of precision farming. So the actual aim of that guidelines were to provide a state of the art about the precision farming in Italy, and the state of the technologies, was more focused on the technology and technologies currently in place in Italy, and also about the current financial resources and incentives that by that time were in place in Italy. The final goal of that guidelines were providing a sort of frame within which setting the financial planning better the financial resources provided already by the rural development programs. So a common frame for all the administrations to programming the financial resources of the RDPs by focus on digital agriculture. Well, since then, the actual programming period is going on, and of course, since the new reforming of the PAC, the CAP, Common Agriculture Policy, of course, this reform put at the center of the new common policy, digitalization, the sharing of knowledge, the reinforcement of linkages between all the forces, all the actors within the AKIS, the agricultural knowledge and innovation systems. The strengthening of these all linkages between the different actors is at the center of the new PAC, and the digitalization is seen as a strategic objective, which is also instrumental to the modernization of the PAC. So, of course, it was necessary for Italy, for the Ministry of Agriculture, to put, assess the state of play of digitalization in Italy, and of course to define a national strategy for digitalization, which we should conduct, of course, the administrations and all the stakeholders, the actors, all along this digitalization in agriculture. So this process started in last summer, 2020. It's been a process which included some meetings with a number of actors between May and end of July. These actors, I mean, I want to stress this word actor, because they are not just a stakeholder. All these actors, researchers, advisors, businessmen, from machineries, of course, technologies providers, and the mass media, farmers' unions and farmer-based organizations, and also education representatives of the world of the education, and the university, high school, and so on, were put all together to discuss about the state of play of digitalization in agriculture and the way forward. So in view of co-visioning how to continue this process of digitalization in agriculture in Italy, and how to set up this national strategy. So they are not just as stakeholders. It was not considered a consultation of the stakeholders. It was just because they will be actors of this transition toward digitalization in agriculture in Italy. And our aim was to define a common vision on how to develop this strategy. So the way forward, what would be our overall approach to this national strategy? First of all, a systemic perspective. We need to understand that there are not single actors acting for their own business or whatever. We need to have a complete picture and think about a vision about the systemic. Digitalization needs to be, and this is well focused in the reform of the CAP. Digitalization will be instrumental to modernize agriculture, and this will be also a tool, an instrument to fuel and to enhance the knowledge flows within the agris. So the systemic perspective is important because we need to have the complete picture and think about the system. And we are within a system. Each actor needs to be linked to the other, and this is need to be well developed. And so it's just certainly a different perspective, no? Of course, there's also the need to reflect the different perspectives of the actors, because they have already different objectives in and dealing with digitalization in agriculture. So multi-actoriality approaches must, of course, and digitalization should be a common path toward a more innovative agriculture, of course. The end users are at the center of it. And when I say end users, these are farmers, but these also are advisors. These are, I mean, because we have a multiplicity of actors. And so we need to put them at the center of this transition. Farmers, of course, needs to be at the center, but there are also other actors. How we define this pathway? There will be, this is a fourfold path, I would say. The first is defining the state of play of digitalization in agriculture. We need to fix some points, the context to start from. And then the second path is about enhancing digital competencies, which is more in line with your project, with the Sparkle project. Then the finalization of this national strategy for digitalization in agriculture, which will be focused on promoting the investments in digitalization, and then accompanying the implementation of this strategy through monitoring and evaluation methodologies. So the first step, state of play of agriculture in Italy, what we will do, and I repeat, this all will be done together with the actors, because we will have a sort of cabina di regia, a sort of a round table with representatives coming from the different representatives of the different actors. So the state of play, we review the main technologies, technological innovations already in place in Italy, the overview of the available digital platforms, decision support services, blockchains, everything which is already existing, which can be used already in agriculture. We will carry out a market analysis of the technologies, technological solutions, the assessment of the needs of the end users. Of course, this will be at the basis of for the development of the national strategy, so analysis of the barriers, reluctance, expectations, and so on. We will run a complete picture of the relevant institutions, which, of course, need to be more interconnected together with the actors and all together between them. And also, we will render a set of the complete set of incentives, financial incentives in favor of digitalization in agriculture. We will carry out also an information campaign, basically through the Rural Development Network, which is very close to the farmers and to the advisors, trainers, and so on. And we will start an interinstitutional dialogue. So at the end of the day, this action will bring to the report of the state of play of digitalization in agriculture in Italy, but also a lot of more than document, media, a mass media campaign aimed at promoting the already existing innovations in agriculture. The second action will be focusing on enhancing digital competencies. This is also more in line with the Sparkle project. The aim is, of course, enhancing all the digital competencies. The digital competencies of all the actors, which will play a role in agriculture, starting from the advisors, the trainers, and also the farmers. So the aim here in this action is the perspectives in this action is connecting the transdisciplinary know-how about the knowledges, correlating different knowledges on about digital competencies, because they need to understand all together. So achieving a common understanding of the digitalization and its role within its function in the modernization of agriculture. So there will be a plurality of rural end users of all the digitalization of this action about enhancing digital competencies, and a focus will be done, of course, on tailoring the actions meeting digital competencies, tailoring these actions upon the real needs of the actors, advisors, and the farmers. Why I talk a lot about advisors? Because we need, of course, the advisors to support farmers in dealing with innovation. So we need to enhance the competencies of both of these types of actors. Enhancing digital competencies will take will be set upon some key actions, which will be interinstitutional cooperation between the different ministers and the different, of course, actors belonging to the universities, to the agro-technical institute, to the farmers' unions, and so on, all together to understand better how to define plans for enhancing the digital competencies in agriculture. The RNN, the National Rural Network, will be the mediator of all these knowledges. I mean, because also there are different languages, but in any case, the National Rural Network can do a work of systematization and echoing, of all this knowledge. We will create a network of knowledge, because the roundtables, will not fix a group of people working all together until the development of the national strategies, but the network of knowledge, we will create a network of different knowledges, different actors, which will also variable according to the needs and the different phases of working. There will be also systematization of the current digital learning tools. I mean, the tool developed by this project, Sparkle project, will be systematized, and of course we will echoing this tool and disseminate, of course, also these tools which are currently in place, but probably less used by the end users. And the aim of this action will be to create a common framework, a national framework on digital skills. So which skills needs to be done, needs to have the advisory services and also the farmers to deal with the digitalization. The importance of this action is to achieve a common understanding, common vision of what are the competencies which are needed, how to communicate the digitalization, how to achieve a common framework for training planning. Achieving a common framework for training planning about digital competencies. We need to set up common languages about the digitalization among the farmers, among the advisors, among the input providers. So this is something that we need reclaim calls for common ground based on training, based on capacity development in general from all the actors. Third action of this path towards the national strategy is the national strategy, which in principle should have been from 2001 until 2005, probably will go further. The aim, the main goal of this strategy is to achieve this common vision about the targets, about the object, the results, the changes, the transition we want to achieve, but also to promote investment, more investment in farming systems on digitalization. So this will be done through an information campaign on what is already existing in place about digital, not about the digitalization, but about the financial incentives and opportunities which are already in place, but probably fragmented. I mean, the communication, the information about these incentives is fragmented across the different ministries and across different providers of these financial incentives. And we will also set up a CARP. We will also set up schemes for integrated intervention in digitalization to be financed by the CAP, by the National Strategic Plan and the Rural Development programs. So integrated schemes which provide the farmers investment, but also training, vocational measures of interventions and cooperation together with the advisors and the input providers. This we will follow it by, of course, public events, cycle of webinars, and so on, which are already conducted, by the National Rural Development Programs. So, likely the monitoring systems, the national strategy will be set up together with a monitoring and evaluation system. Here, the aim is to achieve a common framework. Digitalization is quite new, and there are still not competencies on how to monitor and how to evaluate. There are no tools to monitor. There's a need to set up the system for monitoring and evaluation of the strategy and the results of digitalization. Here, the focus will be also especially the effects of digitalization and the benefits of digitalization at farm level. The farmer is very important, is at the center of the entire strategy, and we need, of course, to accompany him, also to inform him about the benefits and the effects of digitalization, but to assess whether all these investments at one point will achieve the modernization and the benefits, will achieve the expectations of the farmers. So what we intend to do is here to set up a set of contest indicators, because still we are missing some contest indicators which are crucial now to step forward, and set up targets for what we want to achieve in terms of the strategy and the CAP strategic plan. This will be included also in the ex-ante evaluation of the CAP strategic plan, and we will develop also evaluative approach and methods for the future to assess the effects, the benefits of digitalization in agriculture at farm level, and the wider perspective of the system, the agricultural systems in Italy. So for me, I finish here. I'm open to any question if you want.
Now I will give the floor to Marco Vieri. As you know, Marco Vieri is the project coordinator and scientific coordinator of the Sparkle project, and is full professor on biosystem engineering at the School of Agriculture at the University of Florence.
And my role now is to present the Sparkle project overview and main inputs. What have been the objective? The objective has been fostering the introduction of the new paradigm in agriculture and in sustainable precision agriculture, and more supporting the digitalization and high-tech farming, providing new competencies as agroelectronic, agroinformatic. Thank you, Ms. Simona and Dr. Pazzarano, for mentioning end-user centered and the competences. We need new agroelectronic, agroinformatics, analysts, not different competencies, but joins in full competences. Is generally accepted that precision agriculture is an inevitable factor. but they foresee about the development, not respect the reality. Why? The educational system is the problem. There is lacking all around Europe about educational system in a holistic vision on precision agriculture and oriented on sustainability. Some universities have courses, but in fragmentary ways. There is hence a gap in the educational system. What are the problems? There is lack of innovation, potentiality, self-awareness of farm competence, a lack of knowledge transfer on sustainable precision agriculture, the lack of sustainable and precision agriculture knowledge and entrepreneurial skill of agricultural science student. The focus of Sparkle is about entrepreneurial skills. The lack of entrepreneurial education offered to the student of university, high school, and so on. So move the focus from technology and project procedures to the needs. And we think that our approach is innovative. Not so innovative because the innovation is often always parallel in the people that deal with innovation. And we have listened the relation of Simona. I think what is moving at ministerial level. So we need to think to change the mindset, to think a comprehensive ecosystem involving the whole agriculture ecosystem. From the point of view of technological issues, we need not only to the technology, but to the ecosystem and the territorial local ecosystem in terms of provider, service, consultant, human capital, educational tools, and government. Designing the future of the sector and provider the required skills, mobilizing digital knowledge through academic students and farmers. The Sparkle assessment is composed by 4 universities from Italy, Spain, Greece, and Portugal, and is focused on Mediterranean scenario. 4 companies providing advanced service to companies or farms. 3 farms already adopting precision agriculture technologies. And what has been the pattern of the achieved result? First of all, the focus on training need assessment in terms of future trends, with preparation of supporting documents for students and for precision agriculture education, with the results of the foresight analysis, state-of-the-art and future trends in technology, advanced technology, digitalization, robotics, and to precision agriculture concept, and business plan collection. The further step has been e-learning, training, educational package preparation. as to say, definition of the learning course architecture, selection of topics and material collection, and the construction of the Moodle e-learning course. The pilot test has been focused on 4 areas. Why? With which technologies, with which opportunities and constraints, with which entrepreneurial tools. Divided into 12 lessons and 56 topics and tested until October with more than 400 students. And for 3-4 groups on each country, the business model competition with an entrepreneurial experience. The result is the Sparkle e-learning course that is open access, free to everyone. And you can see the link, and please use as and develop and enhance in your teaching, in your entrepreneurial meetings, and so on. These are resources you can use whether you want and in which you need. The course is designed for university students, academics also, school students, agri-entrepreneurs, service providers, who wish to deepen their knowledge of sustainable precision. I have to focus on our experience. Thank you, dear partners. Our experience created a generative learning community, a new approach. Sparkle grew as this kind of generative learning community, focused on targets that benefit directly from the project output, on the partner community itself that developed in a new learning processes. The network between the partners gave life to a system of collective construction of knowledge, negotiation of contents, not without problem, but with an enthusiastic curiosity about the future, also in our expertise field. The kind of approach that focuses on participation and negotiation in the academic of European level opened the path to a new approach. Personally, I have changed my course for 50%. My focus, the topics of the course and the approach of the university course have been changed about 50%. This represents a turning point of the method of learning technology in agriculture, and I am very proud. And thank you again to all the partners, all the teams. The course lasts 25 hours, includes, as I have already said, 4 general areas: sustainable precision agriculture overview, the agronomic rediscovered vision, not after the 7 decades of green revolution, with an simplification and normalization of agriculture procedures. This is a new mindset in agriculture management. And then the second, technology. And we are, the academics are especially agriculture engineering and economists, but we have changed our approach from technology to needs, in which applied and adopt technology. And the third, social and economic aspects, and the fourth, the tools, the entrepreneurship in farming. 12 lessons in total and 56 units. The course is designed to cover a multitude of technical, social, economic, or environmental aspects, and is therefore a holistic approach to precision farming and related entrepreneurship. And we would like to offer to all of you this course to enhance, to bring ahead the knowledge with this new holistic systemic approach. The resource. The teaching materials and architecture have been designed on the basis of a primary needs assessment research conducted on a large number of European university students, researchers, and farmers, with focusing on the training needs, focusing on foresight and applied technologies, tool for designers business model canvas, the milestone point, the simple tools of business model canvas that permit us to allocate our expertise in a multi-actor scenario, a multi-vision scenario. Robotics and high technology for future agriculture, and the business model collection, an astonishing experience among farmers and entrepreneurs. And the Sparkle project developed the website sparkleproject.eu and some social media, Facebook and Twitter, and we will maintain a warm social communication. Thank you very much. Thank you to my to the crew I belong in Florence, but thank you to all the partner and to all of you that follow this final conference. Thank you.
The next three presentations will be given by three of the professors that took part to the project activities on behalf of their respective universities. The first one to give a speech during this final conference is Professor Thomas Bournaris. He is assistant professor at the Aristotle University of Thessaloniki, Department of Agricultural Economics. He will go much more in detail on the Moodle platform, the e-learning platform that was developed during the project implementation, and as Marco was saying, is open access for all the users or teachers, professors, or all around Europe that want to use it. Thomas was one of the main authors of the development of the platform, so it is a pleasure for me to give him the floor and ask him to present the platform. Good morning, Thomas.
Good morning. Thank you very much for your invitation to participate to the final conference of the Spark project. Okay. As Alessandro said before, I was responsible from the Aristotle University team and all the partners to develop and create the Moodle platform of the Spark project. Our university team was consistent from Tassos Michailidis, Efstratios Loizou, Stefanos Nastis, and Maria Partalidou. They were responsible for other work packages of the project, and I want also to thank all of you for the great collaboration that we have and for the results that we have achieved. So, as Marco said before, one of the aims of the Sparkle project was all the learning materials that were produced for the sustainable precision agriculture, all of course in English language. All these materials to be free to access for all the target groups and especially students, and to give to them and who will be able to use them. For achieving this goal, we have created the Spark e-learning platform, which is one of the main deliverables of our project. So Marco told you about the website address. I will repeat it. It's on the sparkproject.eu/Moodle. It's the Spark e-learning platform. We, after many discussions about the learning management system that we had to use for creating this platform, we finally agreed in the Moodle open source LMS. The Moodle is one of the best platforms for virtual or blended courses, even for supporting face-to-face courses, where several resources and interactions need to be available anytime. Also, Moodle is one very user-friendly platform, and also it's used in many universities around Europe, and of course in our university, in Aristotle University of Thessaloniki. The hosting of the platform is also on the web servers of Aristotle University of Thessaloniki, and we will also want to thank them for supporting us in this project. Now I will present you the platform briefly because the activities that's on the platform and many activities. This is the home page, the introduction page of the platform. We wanted to be, as I said before, a user-friendly platform, a platform that is very easy to use, but the contents and the materials that are inside this platform are the main element for it. The introduction page has the first information about what you will learn in the field of sustainable precision agriculture, what skills the users will gain from this activity, the target audience, the main four areas as Marco presented them before, the content information for the 4 countries. We had different emails because we wanted to give the opportunity to the students to have to speak or to give us feedback in their own languages, and of course the social media platforms that we used. As regards the e-learning materials, the Sparkle e-learning materials have the following essential characteristics. They are free to access, they have clear division of topics, all materials are in English, and the materials are composed of various media. We have video lectures, texts, slides, embedded quick tests and quizzes, and final tests in its lessons in order to verify the learning effects related to the contents of each module. Now, as regards the free to access materials, as also Marco said before, all the materials are open access. We get a license for Creative Commons. All the materials are published and took digital object identified number by the Firenze University Press, and I want also to thank them, and I also want to thank Stefania for her efforts in order to achieve this goal. And as regards the clear division of topics, we have 4 categories according to the Spark areas that was agreed in the previous work packages. The first area is the SPA overview. It has 2 lessons. The second is the technology with 7 lessons. The third is the social and economic aspects with 1 lesson with many topics. And the fourth is then the entrepreneurship in farming with 2 lessons. And of course, after the first pilot testing that Marco said before, we also had materials, training materials for the students. These materials are in a different section. We called it training. And these materials also are available in the specific, in the 4 languages of the specific universities. The areas include 12 lessons, and in total, these lessons have about 56 topics. The main courses are, I will just present you, is the introduction to SPA. The first one, the variable systems, positioning systems, proximal sensing, remote sensing, variable rate technology, robotics, data analysis, communications, policy and management, and diversity in agriculture, and finally, sorry, the toolkit for agri-entrepreneurs. Here is how a lesson is presented in the platform. It's divided in 3 columns. In the first column is the title of the lesson, the teachers, and a short image. And in the second column, there are the topics of each lesson. And of course, in the third column, there is the navigation bar from which the user can easily access all the other areas, lessons, and topics. Topic view, it has the main title, the digital object identifier, the DOI number in which gave us the open access, the Firenze University Press, a short description of each topic, and of course the materials that are available for this topic. The materials of each topic consist of mainly presentations in PDF or in PowerPoint. There are in many lessons, in many topics, video lectures or YouTube videos. There are also texts. There are quick tests, quizzes of 5 or more questions, and a final quiz of the whole lesson in order to verify the learning effects related to the contents of each topic. Also, there are some references and, of course, the contributors for each topic material, the names of the authors, and a short biographical notes. As Marco said before, we had the pilot period in which we have tested the platform. It was about 6 months from April to October. 475 users were registered and participated in this process. From this process, we gain and we had feedback from the students in order to improve, to correct, and to make the platform better and very user-friendly, I have to say. And I want to thank also all these students that sent us their comments or their findings and helped us in order to achieve the final platform. Also, there is an option to log in and to register in this platform in order to keep a record of your activities. You can see and have your recently accessed courses, course overviews, your timeline, private files, to see the online users, a calendar, and the upcoming events. And this is how the dashboard view is presented in the platform. You can see if you will register in this platform, you have many more access to specific activities. So, as Marco said, you are free to visit the Sparkling Learning platform. It's the address is the sparkproject.eu/Moodle. And also I want to thank all the participants that created the material, gave us feedback, and all the partners of the project for their great collaboration. I will.
Thank you very much, Thomas.
Just wait, Alessandro. I will share for a little bit the platform in order to see. Can you see it?
It's working. Okay, perfect. Thank you.
Okay. Here is the Sparkling Learning platform. It's the first page as I presented you. Here are the lessons and the topic areas. I will give you a view about how the lessons are presented and specifically it's the topic. Here is the lessons and inside there are the topics. And I want also to say that all the materials of the platform are embedded objects in the platform. You can see here how a text is presented, how presentation is presented, and of course, how a video is presented inside the platform. Also, I want to say that all these materials are downloadable and all the users can download them and to see or read them without being online in the platform. Thank you very much. Thank you, Alessandro, and thank you all for your attention.
Thank you very much, Thomas, for your presentation. It was really useful for showing all the participants to this conference what we have done, also the effort that all the partners put on the project for developing such relevant and huge amount of training materials on sustainable precision agriculture. Now it is my pleasure to give the floor to Professor Costantino Valero. He is Associate Professor at the Polytechnic University of Madrid, Department of Agriculture and Forest Engineering. In his presentation, he will discuss about a very interesting topic, which is the Sparkle process creation content, because it is true that one of the main results of the project is the e-learning platforms and all the other additional materials and resources that were presented by Marco Vieri before, but it's also interesting to know and to understand how the process creation development happened, because it was sometimes challenging, always always funny, but really interesting to know. So it's my pleasure to give the floor to Costantino. Good morning, Costantino.
Good morning to everyone. Thank you, Alessandro, and thank you all for being here and for inviting me to give this talk. I will share my screen and prepare the presentation. So please tell me if you can see it. Okay.
That's perfect. Thank you.
Thank you, Alessandro. So yes, my talk will be about the creation content itself. I am here on behalf of the rest of the team from the UPM, but also, which is a very big team, by the way. A lot of teachers have been collaborating here, but also on behalf of all the consortium, because this part of creation has been due to the big effort of all partners in this consortium, not only universities and research centers, but also the hard work of the companies and the farms itself. They have contributed to the creation of the materials of this course. As you have said, Alessandro, it has been a big work, a big effort, but also very rewarding and very satisfactory. So thank you, Marco, and thank you all the partners for it. What I'm going to present? Well, I'm going to present you with the outline of this creation process. I'm not going to give many details. Some of them have been said before by Marco or by Thomas, but we went through these 4 steps in the creation of the course. We wanted to understand the educational needs. We wanted also to understand the state of the art. And then we step into the design and creation of the course materials themselves. And we wanted also to test the course. So if we go to the first step, understanding the educational needs, we wanted to ask some questions. We wanted to know which were the shortages in current educational programs related to ICTs applied to agriculture. And we wanted to know if precision farming, precision agriculture was known at all or to some extent by our students, by farmers, by technicians. So in the first step of this process, the actions that we did were doing surveys, a lot of surveys to our students in the 4 countries, more than 500 surveys, to know if they knew about precision farming and to know if they wanted to learn about precision farming. We did also personal interviews with precision agriculture experts, with academics, and we did also interviews with farmers, with cooperatives, with technicians and enterprises that had previous knowledge about precision agriculture, just to know if they had the impression that this should be addressed in a different way or not. I'm not going to give the answers to these questions because other speakers will do it later in this session or tomorrow. But just, of course, we address that that there were some educational needs to be covered. The second step was understanding the current state of the art. So we question ourselves if precision agriculture is a mature technology to be used widely or not, but also if manufacturers are offering just a small set of commercial solutions, or in the other way, is it a bursting, is it a blooming sector now in agriculture worldwide? And how agricultural robotics will play the role in the future agriculture. So to address these questions, the actions that we did was a very deep and very profound foresight analysis by studying the patents, more than 62,000 patents and scientific publications, and later Dario from R Cuadro will talk about that. And also we did a big dossier on the state of the art on these technologies and on agricultural robotics that will be presented later by CSIC. The third step was the course creation itself. So we had to decide the type of course, the syllabus design, and the creation of the materials. But on which criteria? We had to define previously the criteria. So we said that we agreed that the course should be addressed mainly to agricultural engineering students, but not forgetting the farm technicians, not forgetting the farmers themselves, as we have said before in the introductory speeches. And we wanted to cover not only the state of the art of these technologies, but we want to give the course a strong focus on entrepreneurship and social, legal, and environmental aspects. So with this criteria, we had to decide the type of the course. So we had many meetings, very intense meetings, and also very creative meetings, talking about if it has to be a face-to-face or online course, it had to be a MOOC open course or more traditional course based on published contents, on if we had to use other pedagogical techniques such as flipped classroom, project-based, case studies, and many more. So we had many meetings talking about that and discussing if it was more adequate to use one type of course or the other. And based on the surveys that we did to our students and also to our previous experiences in the academia, in the consortium, we decided that it had to be a blended course showing an online part, but also preparing face-to-face lessons based on materials available on the Moodle platform that Thomas has just presented, but also comprised on with practical sessions, real case studies, and sessions of active entrepreneurship. About the design of the contents, the syllabus itself, well, the general contents were already clear for us from the previous meetings, but we still had to decide how to structure those topics, how much time should be devoted to each one of the topics, and if the same type of materials should be developed for all topics or not. So our coordinator and the team from University of Firenze organized a very creative and fruitful meeting at Thessaloniki. Thanks for that. It was wonderful. Using the World Cafe methodology, in which our consortium was divided into several groups, conformed specifically for that activity, and we discussed in turns the syllable contents, the materials, the topics, and in subsequent terms, we optimize the work of previous groups. And at the end, we reach to a definitive list of topics, to the structure of the course and the order of the areas, to the relative importance of them, and we ended up with some recommendations on the materials. Which materials? Well, Thomas has presented also a bit of them in the Moodle platform. At the beginning, we said that we had to prepare a minimum of one presentation, one written document, and one quiz, one test for each one of the topics and subtopics. But at the end, we ended up with a lot of additional materials, multimedia materials, as you have seen. Who did these materials? Well, more than 40 teachers, more than 40 experts participated in creating this huge collection of contents. It's been a really big work, and it took more than 6 months of collaborative and individual hard work to create those contents. And these contents were also edited by 3 editors, part of the consortium itself, which did a very deep and long work of editing the style, the language, and the contents of all the materials uploaded to Moodle. So you have seen the course, you have seen the Moodle platform that Thomas has just presented with the 4 areas. Area 1, Sustainable Precision Agriculture, Area 2, Technologies, Area 3, Social and Economic Aspects, and Area 4, Entrepreneurship in Agriculture. For me, the most important part is that we have exceeded all expectations. We have exceeded our own requirements and the requirements that were written in the project itself. We created more than 35 hours of online materials, a lot of videos, a lot of audios. We have done a really large bank of questions for the tests, for the auto-evaluation tests at each topic and the final test. And we created, as Thomas has mentioned, materials for giving face-to-face lessons and for the business model competition. So for me, it's a big success, the high quality and high quantity of materials that we have put into this course and to this platform. Well, we are in a very difficult situation. So how the pandemic has affected us? Well, the universities were closed, classrooms without students, so there was immediate need for teaching materials. So we decided to accelerate the course start, and we redesigned many of the materials. We recorded more videos, more audios, we commented the PowerPoints, we did collections of online resources, links, web pages, a lot of new materials to complement this Moodle platform for a full online course. And we decided that the pilot course should be launched in late March, 1st of April, free, open to anyone. And we converted the face-to-face part of the course, the practical sessions and the business model competitions, to full online sessions, creating materials for them and planning and scheduling a different type of sessions, virtual sessions in most of the cases. So at the end, we tested the course in this pilot test launch, as it has been said before, in April and ended more or less in October. And the welcome was excellent. Despite the hurry, despite the haste of launching the course, many students enrolled, almost 400, more than 350, and roughly 200 completed all the tests and all the lessons. So for me, it's a big success. These students, were 80% students from the universities, but also a remarkable amount of professionals, of farmers, technicians, people from other companies, cooperatives, etc. And I think this is also important. We included in the Moodle page for each topic and for each lesson surveys of opinion and satisfaction to have feedback from the students, and the comments were very positive. Let me show you some of them. For example, how helpful were the following materials to you? Written materials, PPTs, and videos. Well, most of the students told that all of them were very helpful or extremely helpful. So I think the quality of the materials is quite good. Maybe it has to be reviewed to some extent, but I am very satisfied with it, and I think everyone in the consortium is. About the contents of the lessons, most of the students said that they like much or very much the contents, the same for the structure of the lessons, the same for the length and duration of the lessons. They like very much the length of the course. And about the use of English language, that was an item that was very discussed among us. We were afraid that using English language was going to be a barrier for our students. Well, at the end, they said that they like or like very much the use of English language. So yes, it was also a success. And about how many hours did it take for the students to complete the online part of the course? Well, I would say that the 25 to 30 hours that we plan for, that we schedule the materials for, were correctly defined, what correctly planned, because most of the students had the impression that they needed those hours to complete the course. And just to show some of the comments that we have received, I want to share with you this comment of one of our students. He said, I take this opportunity to thank you all and the teachers of the course, because it has been a really interesting and, in my opinion, a success. If it is repeated, I will recommend it again. With this kind of comments, and we can be very proud of this course. And this is my last reflection. So thank you very much for this opportunity, and I am open to any questions. Thank you.
Thank you very much, Costantino. Yes, if anybody has questions, just please drop a few lines here in the chat, and we will try to collect them and give the opportunity to the panelists and speakers to answer to all of them. At the same time, as we are in quite a late, I will give immediately the floor to Professor José Rafael Márquez de Silva, who is Associate Professor at the University of Évora, Department of Agriculture Engineering. Rafael was one of the other main researchers in the project. He will discuss about the topic interaction between the universities and farms in the Sparkle project, which is another key point and key topic of the project Sparkle. So here's the head for Rafael. I'm giving you the privilege to share your presentation.
I just want to show here a friend of us, a friend from Sparkle. Good morning to all of you. It's a pleasure to be here. It's a pleasure to get involved in this project. This is a nice project because it was some aspects related with something that I'm going to present today. Let's see if I'm able to do it. Are you seeing my screen already?
Yes, we are, Rafael. Perfect.
Okay, thank you. So, first of all, to compliment all the colleagues, all the persons are attending. Here from Portugal, it's raining a lot and it's very cold, so it's good for the farmers. It's a good day for the farmers, having water for agriculture. I intend to speak a little bit about the interaction between universities and farmers in the Sparkle project. This is a very challenging team. but I think first I will start to speak between interaction between universities and farms first. As you know, I don't know, but most of you maybe know that this relationship, universities and farmers or universities and society, is an important relationship because our societies need knowledge and competences to grow. And normally, but normally there are two different sides with two different needs. Normally, universities are selling technology, are selling knowledge, are selling competences, are selling articles, and farmers normally are buying problem solving. So this relationship sometimes is not a very easy one, but none of them are. I believe that the relationship not always is easy, but at the same time challenging. So most of you have talked about innovation, and I believe that that's the right word that we have to use in this type of interaction. I think farmers have to innovate. I believe also universities have to innovate because most of them are speaking sometimes different languages. Farmers need to resolve problems. Their language is to survive. They farm, they company, their families. Universities also need to be aware of this type of problems, but sometimes they are discussing and talking other type of languages. And this is a challenge, especially for Europe, to deal with. Just to present you a slide. I love this slide. I use it very much in my classes. And because sometimes people, and also farmers, and also teachers, and universities think that technology is enough. I believe technology is very important, but per se, technology doesn't serve for nothing. But incredibly, if you see in this photo, the technology, it's a 1 liter water bottle, and let's say a tube that can control the doses of water, like a drop irrigation system. But it was recycled from, let's say, from else bottles of serum. And as you see, the technology here is something very simple as a bottle of water. And if you look for this, the system that are supporting the bottle of water, it's a let's say a wooden stick that the farmer cut it in the forest nearby. So, but if you put it there, a bottle of 5 liters of water, the system and the technology has to be different, completely different, because the stick could not support the weight of the 5 liters of water. So it's interesting that sometimes most of the people, universities and also farmers, I think they think that technology is enough, but technology is not enough. I think Marcos and other previous speakers have spoken a little bit about this, and this is very important, inclusively in learning and researching and whatever. We have a lot of technologies already, a lot of them. And one of the greatest problems in the world, in Europe, in different countries, that there is a lot of technology, but there is not an uptake of this technology by farmers. And this is very interesting because there's some way, and I believe Sparkle is an important project on this type of problems. There must be a way of trying to understand what is really important for who, when, in order to the farmers uptake the technology in their favor, because I think there is very good technology, but there is a lot of resistance. At first time, we can think that the resistance are economic, but nowadays, with the experience that I have on the ground, on the market, I believe that the resistance is not technology. Sometimes all technologies as a soil sample is still not used nowadays in farms, in farming. Not all of farms, of course, all farmers, but sometimes all technology that we know for agronomy and agricultural engineering, that is very important to have this information in order to set up a fertilization. So even this type of old technology, collecting a sample, a soil sample, and analyzing it, sometimes is not used. So we are worried about the new technology, but even then, the old technology sometimes is not used. So this is not a problem of technologies, this is a problem of innovation. And the entrepreneur uses the innovation to produce economical value. And this is the great deal about this type of project. So, in resume, I believe that farmers and universities need new competences. Farmers need competences, and this course, the Sparkle course, is a very good start. There is one barrier, one resistance, the language, but maybe we can resolve it in the future. But for sure, farmers need new competences. But universities also need new competences in terms of teaching, as Marcos said, about the questions of entrepreneurship and things like this, because universities sometimes are very, how do you say, worried with other aspects of their lives and forget the real world problems. Other aspect that I believe that is very important with farmers and the universities is the networking. One farmer doing one experiment in one field learn something. If it was 20 farmers doing one experiment in one field, it's 20 times more knowledge and more information that the team of farmers can do together. So networking is very important. If we think that in this type of world, working alone is a solution, is not a solution. The network is really, really important. And also with universities. Universities sometimes they are fighting for students, but alone, I believe they will not resolve the problem. And for sure, they need also the real world problems in order to grow in terms of knowledge, in terms of new solutions for society. And I believe also the new goals that they are needed. A farmer, when stand up in the morning, he has to have a goal to improve their farm, and maybe it's doing a small soil sample if it doesn't, if it has done before, but to reach the level in order to increase his or to improve his system in the farm, and also universities, I believe they have to have new goals. They have to have the goals of resolving problems in society, to be focused on the problem solving, to teach innovation processes to students, because most of them are formatted to other type of systems, not in this type of innovation and entrepreneurship aspects. And so new competences, networking, and new goals are needed in this type of interaction between farmers and universities. And so now I'm prepared to speak about this type of interaction between farmers and universities in the Sparkle project. I just have one more slide. I believe that really students, farmers, universities, entrepreneurs have a very nice chance, a very beautiful one, I believe, because if they can innovate socially, this will make a big and huge differences in the future. I believe sometimes technology helps, but social innovation, the way that we can resolve problems together and with the technology, with the processes, it's more relevant than everything else. So I believe also that in this project we had a lot of social innovation. We had for sure we had problems in the processes, but we were wise sufficiently to discuss together and to reach to a final product that we have to be proud of. With this, I end my presentation, and thank you to all of you and to be part of this project.
Thank you very much, Rafa.
Good morning, everybody. As Alessandro said, my name is Angela Ribeiro, and I am a researcher in the Center for Automation and Robotics and belong of the Spanish National Research Council, also called CSIC. CSIC is the biggest research organization in Spain and the third in Europe. It is a pleasure to be here, of course, as well as to be part of this amazing queue of the Sparkle project. We start with the session 2. This session is devoted to the technology applied to precision agriculture, and this session we have 5 amazing speakers. I'm sure that we have very interesting things to tell us. So let me remind you all that we have 15 minutes to speak for a speaker. Remember, we have to leave this room at 10 to 13. So please, our first speaker is Alessandro Malavolti, and he's the president of the Feder Unacoma, that is the Italian Agricultural Machinery Manufacturers Federation. And he comes to talk us about the future scenario of smart farm machinery. Please, Alessandro, you can start.
Thank you, Professor Ribeiro. It's quite difficult to talk after professor and scientist. I'm just a simple entrepreneur, so my language will be much easier and much basic than what you are saying until now. I just want to make just a very quick outlook of what is the industry technology right now, what is in the market, and what we are preparing for the next following year. Just sorry, I have problems with my presentation. Page number 2 now.
Yes.
Okay.
Yeah.
Okay. Now.
Yeah.
So, what is just to understand what I'm saying? We call digital agriculture or agriculture 4.0 a technology based on 3 different points. The first one is what is precision farming. Precision farming for us is called agriculture 3.0. There are automatic machines that have electronics on board that help the driver to make very optimized mechanization on the field. Agriculture 4.0 is not only precision farming, but is also automatization of several things, and especially the mix between precision farming and what is the data exchange between other sources, not only agricultural machinery, but also information from the IT system and the IoT system and other systems, both in the cloud on board on the machine. So agriculture 4.0 for us is not only precision farming. Precision farming is present in our machines since beginning of 1990s with the first GPS auto guide. We are much more in deep in the technology up to right now. Agriculture 4.0 is just collecting data, exchange data between different sources. So what is present on the market right now is there are more or less 5 different technologies. Probably the most known is the number 3, what we call GPS or auto guide, that was invented in North America in the 90s, as I told you, and now is quite advanced. I think the auto guide in the tractors or in the combine are much more sophisticated than in the car business, for example, right now. So we have reached a very good point in the technology. Not only that, we have tried in the last few years to enlarge the talk between tractors and the implements, and with what we call ISOBUS protocol, in order to give the possibility to the farmer and to the driver to control everything about the implements. Until now, we just can control the tractor or the combine on one single machine. The third point is the use of other sources, as I told you, especially what we need some images, we need data, and we collect data mainly from satellite, from the geosensing, or from drone for images with infrared or other type of picture. Then we are developing, and this is a very good chance for the future, the vision sensor. So we are looking with our machine to the field to see if there is anything wrong and to correct the nature. The fifth technology that is present on the market are the sensors that we put on the field, not only for meteorological reason, but also to collect other data from the field. So sensor inside the earth. Some example. I'm sorry, these are only in Italian, but I can just show you the images. We are quite advanced right now in the seeding. Our seeding machines now are quite technological. So we can just design on the field where we have to seed, and we can make what we call high-speed seeding. And we can also try to change the line of seeding. So each and every seeder or line of seeder can be moved in dynamic mode when we seed, we make the seeding in the field. And this is quite advanced for that. And this will save us seed, will make the very correct agronomic process, so we leave to the seed enough space in every circumstances, and we use less fuel for that. Another technology that is quite good is what we call the smart dip. So the sensor just study the hardness of the soil and the humidity on the soil, and we just put the seed in a different height in the ground to optimize the output for the plantation. And this we can make in a different way in the same field. So for each and every meter, we can just change, if our map is correct, the deepness of the seed. Another technology that we are developing right now and is available on the market is what we call predictive feed rate. So with drones or satellite, we just can study if there is a part of the field that in which there is much more of cereals or whatever, or soya, and we just can say to the machine, in this part of the field, you have to slow down because you need to have more power or more capacity to collect in the harvesting. And we can make it in dynamic way, just receiving the images from the satellite. It's about the spraying, especially for the trees. This we use some ultrasonic sensor just to see if there is a good number of leaves or no leaves or a small number of leaves. Once we have this information for the sensor, we can just adjust in very few milliseconds the quantity of chemicals that you have to spray in this meter. So we can just save chemicals on the field, on the trees, sorry, and we can just optimize that, not in order not to have any waste or to use the correct quantity. What happens the following year? We are working in to have to improve our auto guide. We will have more and more automatic machine. We will have more and more sensors on the field. We are working on to having two machines that are working together without any interference from the human. So the two machines combine, and the tractor with the track after that are driving together. to avoid any error. But this is just the next 2 or 3 years. Just have a look to the next future. We are talking about robotics. Robotics is a very nice word that came from the Czech language. I discovered it a few years ago. In the Robota, in the Czech language, was a book of a fantasy a writer in the beginning of 19th century, means hard labor, heavy work. So for us, it's just a part of mechatronic engineering, and just help us to not to use the human work in agriculture. Speaking, see a very good future of robotics in two fields in agriculture. The first one, and in harvesting for fruits, vegetable, everywhere. Greenhouses, open field, hydroponics cultivation that are very nice thing for the future, especially in the cities. So I think that in the next 10 years we will develop a lot robots, but just in this one. I don't see a good development of robotics in what we call open field for cereals, for potatoes, or for soya, because the cost of labor per hectare or per tons of products in this case, especially in cereals, are so low that the investment in robotics is almost unuseful. In vegetable, for example, in tomatoes or whatever, the cost of handwork is huge, and we don't have in several countries this. We need immigration, and this creates social problem, whatever, or a political problem. So all the industry, livestock and fruit and vegetables. These are some examples. These are prototypes, are not in production. We have the tractor without any driver, but we have also other machine that can make harvesting or seeding or whatever. As I told you, are just prototype. I think that we can see on the market this kind of machine in the next 10 years. No less than that. In the livestock, robotics is already available. There are some companies, name because I'm from an association, so we are a lot of companies that already are making robots for the farm in the livestock business. For making, for feeding the cows, to clean everything, and the robot is already on the market. The only problem is the cost, and I will talk about this later. Then there is also some very interesting experiment and prototype in the what we call spraying, but it's not spraying, is a mechanical spraying. So we are talking about weed, so the bad plant. We can, with sensor, with very sophisticated sensor, vision sensor, we can just have a picture of the weed and saying to the robot to just eliminate, to cut this weed without touching the other material, vegetables, cereals, or whatever. So this, I think, will be much nicer especially for the environmental in the next few years. This technology is not available only on robots, but also on traditional agricultural machinery. We just need a very particular sensor and very particular camera with high definition and a very good chip processor to study in 5 kilometers per hour, 10 kilometers per hour, all the images, and to destroy the weed when the tractor is going on the field. Last but not least, this is just a picture which is what's happening in the world, in Europe, and I'm from Italy, so I just give you just a picture of Italy, of what is the market of agriculture 4.0 and 3.0. The last survey was done in 1997. Now we have grown a lot. And what about robotics? So in the world now, the precision farming or the digital farming, we have, I think we are just in between the 4.5 and 30%. I think now we are 7-8% at the moment, 2020. We hope to reach 13-14% in 5 years' time. Robotics is almost nothing. It's something more in Europe, also now, and something more is the last few years also in Italy. We have just some amount of money from our government to invest in this kind of technology. So just to give a very quick idea, the problem is not technology. We can develop more technology. We have already a very good technology. The only problem is the cost. The cost cannot be paid by the farmer. The cost, I think, can be paid about this kind of agriculture only by the government. So to develop this kind of technology, we need the sustain of the government, because we have to use less and less pesticide, we have to use less and less fertilizer, and we have to conserve much more our earth. This is the picture. The technology is available and will be available in the next few years. The only problem is the cost of technology. Now is too high to be paid by the farmer, except very few cases. Thank you for the attention.
Thank you, Alessandro. A very nice talk. I have only one comment about your talk about robotics. You put the robotics into the mechatronic engineering, but robotics for fields need to be intelligent, because they need to have sensor, process information, take decision, and then act in the country. And this means that robotics is into artificial intelligence.
Absolutely.
Okay.
We start from the still, let's say, but the 90%, 95% of the value of robotics is, as you said, on electronics, but mainly on the software. Because, as I told you, we have the technology. So to reach the level of technology we need, not use pesticide, use very less fertilizer, whatever, we just need software. Because we have to, and we need some artificial intelligence to use this enormous data that we have, gigabytes of data every second, and to be transformed in action. We need to take action. The mechanics and electronics is, I don't say simple, but we already have. We have just need the software to make it available at reasonable cost with a good result.
Well, it's a combination. It's a combination of artificial intelligence and mechatronic. Okay, thank you. The second speaker is, let me see, is Dario Brugnoli. He is a natural language processing unit leader in the company R4. He comes to talk us about foresight analysis, technology in the present and in the future of precision agriculture. And let me give you the power. I'm sorry. Yeah. Now you have promote.
Okay, thank you.
You have the power.
Okay. Good morning. I'm Dario Brugnoli from R4. We conducted the foresight analysis in the Sparkle project in order to assess which are, let's go into the goal of this analysis, which are the most growing technologies in precision agriculture at now, in order to be able to build learning contents for the project. So for the development of the courses inside the Sparkle project. And so in order to focus well these learning contents on technologies that are with a high probability diffused in the next future. The boundaries of our analysis was on the type of crops. The partnership have chosen viticulture and arable crops as two data sets to analyze because they are the most important kinds of cultivations in Europe. The cultivation steps were from planning the field to harvesting, so no further step in the agri-food supply chain. Not the limitation within the definition of precision agriculture for technology. So every kind of ICT and robotics and mechanization technologies seem to treat different agricultural entities in accordance to their specific needs. No boundaries on geographical limitations, so no boundaries on the kinds of documents filed in the different countries, and a limit in the time in which these documents are filed, because we started from 1990 for patents and from 1985 for scientific papers in order to focus only on the youngest and the newest technologies. The methodology with which we conducted this analysis was, of course, stratified in the two data sets, so viticulture and arable crops. We conducted a cluster analysis in order to find technological clusters in both of the cultivations. And then in each clusters, we conducted an in-depth analysis in order to find the specific technologies applied in every cluster. So this analysis was very wide and very deep. But of course, in this presentation, we also have a quick synthesis of the results. Data sources, as I told before, were patents in order to assess the applied research in this technological field. The source is PatStat, that is the database of the European Patent Office, so it's complete of all the patents in the world. And for scientific papers, the database was a Science Direct, so Elsevier as a publisher, in order to assess the basic research as then applied research. So by assessing both of the data sources, we were able to find the market and the industrial interest in these technologies, but also the basic research, so let's say the public interest in these technologies. Let's say a quick look of the results. These two tables you see for viticulture and arable crops, the number of documents that we found inside the databases about these kinds of technologies. From an overview, you can see that viticulture has a number of documents lower than arable crops, maybe because arable crops is wider as a kind of cultivation. It embraces a lot of different cultivations, but also because there is maybe an interest from industry and from universities more in arable crops than in viticulture to develop the technologies and applications. The data clusters that the technological clusters that we found are divided in data processing, measurement and data detection, data transfer as enabling technologies for viticulture, and we can find them also on arable crops, but also we found application technological clusters that are harvesting and handling and vineyard care for viticulture, and harvesting and manipulating, planting and soil working, agricultural vehicles, and irrigation and fertigation for arable crops. From a view of the difference of the gap between patent families and papers, we can assess if the technologies are in a phase more translated to the basic research or the industrial research, so the applied research. From these charts, we can assess the geographical distribution of the patents. So let's say the interest, the industrial interest for the market and for areas of production of these kind of technologies. In both cases, we have a similar distribution with USA, that is the biggest jurisdiction, with around 30% of the patents. European patents are around 13-14% in both of the areas, and the others are percentages that are lower than 10%, except for China in arable crops, that is around 13%. WO patents are patents that are applied in around all the world, so that are only applications of patents around the world. From the affiliations of papers, we can say geographical distribution that is similar, but with some slight differences. For instance, in viticulture, you can see several American and Chinese universities, and also in arable crops, you can see a huge amount of papers from Chinese universities, but also from American universities. Let's see the distribution in time of the technologies. Here is a chaotic, let's say, graph for the comparison of the different technological clusters normalized in order to compare only their trend in time, so not in their absolute value in time, but their trend. If we extract this trend, we can say that in viticulture, the data transfer and vineyard care technological clusters are the fastest growing. Measurement and data processing clusters are the secondary of secondary importance, and the harvesting pruning cluster is very slowly growing. Similarly, on arable crops, we have the same graphs in which we have, if we look at the trends, irrigation, fertigation, planting, soil working, and data transfer clusters that are the fastest growing. Measurement, agricultural vehicles, and data processing that are at a second part, and a second pace. And harvesting and manipulation, similarly to viticulture, that are the slowest growing cluster. If we go a step further, a step deeper, we can see every single technology that is involved in each cluster. So in this table, there is a very high level synthesis of this kind of analysis we conducted. And if we have the same color on similar technologies, we can see that there is a huge repetition of some technologies for several clusters. If we remove control systems and sensing systems that are very transversal, very horizontal technologies, and so they have impact on almost all the clusters, we can see that optical systems and imaging processing are very transversal, but also aerial vehicle and navigation solutions. Some observations from a general overview. All the technological clusters show growing trends, even if at different rates. If we see at the technological life cycle, considering the rates of growth, but also the number of documents and other kind of factors, we can distinguish between emerging and growing technologies. In viticulture, almost all the clusters are in the emerging phase. Even if in the arable crops there are some growing technologies in the growing phase. And in most cases, patents and papers are in accordance. All the trends are in accordance. Final insights. We have as the most growing technologies, planting, soil working, irrigation and fertigation, data transfer in urban crops, binary care and data transfer in viticulture. And as single technologies, we have primarily image processing and optical system as transversal technologies, and secondarily navigational solutions and aerial vehicles. Many thanks. This is obviously a quick synthesis. If you want to see the entire analysis, there is the full document in the Moodle platform of the project that I advise all of you to subscribe and to follow the courses. Thank you.
Thank you. Thank you, Dario. Very interesting presentation. Our next speaker is Professor Manuel Pérez Ruiz. He is professor at the University of Sevilla, Spain, and he is co-founder of the AgroSap and AgroPlanning startups. He's come to talk us about for studying innovation in precision agriculture. Let me give you the power, Manuel. Now you can start.
Okay, thank you, Angela, for the presentation. Yes, I have the double role here. I'm professor at the University of Sevilla, but also I'm co-founder of the company AgroSap. SAP is a Precision Farming Corporation created in 2007 at university spin-off, which has the goal of developing an system of integrating management of the agricultural operation based on a new set of tools applicable to agriculture, like GNSS technology, sensor, UAV, actuator, controller, everything related with this. The company has also the mission of improving the traditional agriculture management, basically in the south of Europe, introducing new techniques and also new systems, a guidance system, geomonitoring, or variable rate application. So for me, it's a pleasure to be here with you guys and to share my presentation and comments and aspect for our company, and also how this company was involved in the Sparkle project. Basically, we are in the Sparkle project because our company is commitment to the future of agriculture and getting new skills for agricultural technician. We are talking about mechatronic, robotic, UAV, big data. So we need a new skill for a technician. So for that reason, this company is involved in the Sparkle project. Try to share our knowledge to create this new course. The company has been preparing of a learning module and was coordinating the activity related of the business model competition. Let me show you some slide to try to show you how the agriculture is changed right now. So now we have to put the focus, not just in the producer, but also in the consumer. So it's very important, everything related with the traceability, reliability, with everything that happened in the field. So in the short future, the consumer wants to know. So we are going to pass to product-centric model. We are going to the data-centric approach. This is, how we see the agricultural sector change right now. Here, okay, we can put behind the agriculture 0.0, 1.0, 2.0, but in reality, right now we are in the bottom one. It's a permanent exchange network. Okay, so we have to see the agricultural like integrated everything, not just data, not just producer, not just technology, not just analyzing, everything together, system of systems. Okay, so this is how we see the future. Just to remind you that in 2015, Bruce Erickson and Davey, we published the paper that say the precision agricultural survey in this date was a pre-match for customer. When you do the question to farmer to say, okay, what is the precision agricultural survey for you? More of the answer was pre-match for customers. So this is now it's a little bit different. Okay, now the target is in data aggregate among farmers, including those outside the dealership. So this green part, it's a really precision agricultural service. Okay, no just the print map or something like that. So our evolution was interesting because we started working with hardware for farm machinery, GNN's guidance, yield monitor. We are Trimble dealer here in Spain and also in Portugal. Our mission was to incorporate technology, using technology, variable rate application. We found many barriers with the farmer, with the sector, just because the sector, was not familiar with this technology. But our vision is something like that. We have a food management. We have automatized field notebook. We have variability map and sensor. We have the yield map. So everything together is a multi-data integrated solution. And of course, we are going to produce productivity and saving for the farmer. Fleet management, getting predict maintains, automatized field notebook, produce traceability, reliability, variability map and sensor, input prescription map, and yield map can use for crop prediction. Everything together, is the new precision agriculture. So company is focused in these areas that you can see it in this slide. Our planning, GPS, and also prototype lab, very important to involve to students, to new technicians that are coming to the company to learn how, how to carry out this technology to the farmer. Thinking in precision agriculture is not new for you guys, I know, but the right amount of input at the right location at the right time. This is very important. It's also very important the interpretation of this information from designing to implementing project. It's also very, very important. So it's not just it's not solving problem just with data. You need also the interpretation of the data, and you need also the local expertise in each crop, in each area of your country. We are running some electrical conductivity map for variable rate seeding plan, new planting design, irrigation management, variable rate fertilizer. Just some example here about our activity, our day-to-day, some application with thermography for water stress, for irrigation problem, for crop temperature, crop monitoring, soil monitoring, using satellite, using AUV, using ground sensor is also important. Implementing in a different sensor on the vehicle, like tractor or like combine, to get in information from the soil or from the crop is also very useful, and sometimes cheaper than satellite image or AUV platform. Some picture here about we have a different kind of in our area we have different kind of crop, like arable crop and goody crop also. Sentinel here in our area have 3 days frequency. This is also very interesting and very useful for us. And yeah, checking all of this information, multispectral information for for know the different behavior of the crop with the different vegetation index. High resolution is also important, and every day the sensor like that is cheaper and also high resolution. So also we have, like company, we have also chain every day. We have a very dynamic system internal in the company, just for for implementation all of this technology to give the service to the farmer. Just I'm going quickly here in this part because it's just information that we can get in with the different technology that we have in the company, and give value to the farmer. Important thing in the last years was analytical service, advanced data science technique for supporting technical and strategic decision making process. This is a very, very important, let me say, department that is growing every day in our company. With detection and location through analysis of this image like that, just we can put just herbicide where the red part that you can see in the image, it's the weed. Variable rate application map is the next step. The first step was very popular in our area, the guidance system, but the next technology that will be implemented on the farmer will be the variable rate application map. Most of the implement that the farmer is buying right now has this technology implementing. Yield map, you can see counting plants for example, for helping to the for the plant breeding guys or something like that. seeding evaluation, plantation, enrichment estimator, whatever. Also, it's important, and Alexander comment before, it's a ISOBUS technology, also for the connectivity between the implement and between the vehicle. It's very important. Hardware connectivity and truly, this is very, very important. So in this case, with the all-optic technology, we put everything together in a agro-planning concept, just to, you know, the vehicle, the tractor, and combine are all time working on the field. So it's an efficient data acquisition center. So the tractor, like, taking a lot of information, you know, just short video about what all the information that the tractor and the vehicle can send in. So let me go faster in this part of the presentation because we don't have too much time. But let me say something important.
1 minute.
Yeah.
1 minute.
Yeah, I'm finishing. Let me something important. We are talking about data technology, but you know, we need to looking for the actionable information. Not all data is actionable information. We need to looking for the smart business for agri-food sector. We need to include it in our sector, the food chain, traceability, predictive systems, and you know, everything about that. Let me some of our projects here in this presentation that I can share it with you after the conference. Some of our you know, customers, but the really important things here, I think, you know, increase production efficiency, reduce input, and sustainable strategies are the basis of the European agricultural document. In line with this European strategy, from farm to fork, the implementation of the so-called precision or digital agriculture is a fundamental pillar to provide solutions that address the needs of producer and other actors in the agri-food network. So please see the precision farming like the network, like everything integrated. It's not just technology or just data, it's everything together, and also with the new skill of technician. Sorry for be quickly.
Thank you very much, Manuel. Very nice presentation. Our next speaker is João Coimbra. He is the owner of the farm Quinta da Chola in Portugal, which is a family enterprise who manages for 500 hectares and farmland and 2,000 hectares of forest. Now, I'm going to give you the option to do the presentation, João. Okay.
Hello.
Now you can. Now start.
Can you see the presentation?
Yeah. Perfect.
Sorry. Good morning, everybody. Thank you for the invitation for the project. I'm very glad to have these 3 years with you. Now I go to make my presentation. What are you doing in our farm? Like you know, we are João Coimbra from Quinta da Chola, a family company to do farm. We produce cereals and forests in the center of valley of Portugal. Is the good lands of the biggest river in Portugal, and now we are a corn producer by 500 hectares. We produce rice in the center of the forest valley, and we are a conservative areas because we trying to help to our sustainability. Like all farmers, we must produce more with less. Is a big challenge for us because the price is very down, and we must produce. But at the same time, we must bring our best way to maintain the biodiversity, and the farming is helping the biodiversity and not the contrary. How reconcile intensification and sustainability is my first question. And our answer is intensification of the center of the fields, and in the zones, you know, with the margin is negative, we put it in conservation areas. So we must intensification in some areas and reduce the farming to conservation areas. And we try to transition from a chemical and mechanical to a smart farming. It is eco-efficient model. Like Manuel said, we need to change the target, and we must change very quickly. So in our farm, we introduced the precision farming 2012, 14, and now we begin to self-driving. Like you know, all tractors are converted to self-driving. And now we support the GPS, is not need the operator intervention. There are many difficult to do that because there are many whole tractors, but we change some steel wheel to electric motor and so on, and all the tractors now are self-conduction. With this, we can take it telemetry, you can take data. Is the biggest question to recover the data when we work. And for this, I can show you what we do. For example, for spraying, is automatically to put it spraying. In the last time, in the past, it's very difficult to make the spraying, the sprayer in the spring. This is after here is very easily now because the operator is more easily to do the work. Is by centimeter. You use RTK. And the difference now is we don't have compactation too much. We don't use a lot of fuel. Yeah, you can reduce. And now we can put the seeds where we want. For example, here, there are two machines working with the same line, with the same way. And this is very important because we know what you can do with. And now where is the seeds, especially in these big fields, and now we can work by night. We can work with the dust in the summer. We are very dusty days, and it's more easily and more comfortable for the workers. And with this self-guidance, we take data from the lands. For example, here we see altimetry to plan drainage. It's very important with the climate change. We have a lot of problems with too much rain, and there are other years it don't rain, but normally now it's possible to rain a lot, and now we implemented the drainage to the spots we are negative. We are watering the fields, and it's possible to avoid make drainage in all fields. Now we use it only the spots there are problems, not all fields. Is less expensive, and is more important because the drainage is only needs when you are negative zones. The productivity maps, we put it in the combine, and is very important because now we know very well the fields, the variability of the fields, and they are data from very many years, and very important because they are must need to take it by the field and review by an enterprise. Like Manuel said, data is not only, data is not information. Data needs to be correctly observed and put it together to have more and more capacity to take good decisions. And so we plan to organize this data all over the years the same way and the same platform. Now the fertilizer, we bring the law of minimum to reduce, for example, nitrogen. Our goal now is reduce nitrogen because the emission, the nitrogen is 50% power to in our fields to put it CO2 in the air, and so we must reduce the reliance on nitrogen. And to do that, we must know very well where it's possible to reduce. And if possible, we can do it, know it, our soils. For example, electroconductivity, all farms are recover the data from electroconductivity. And now it begins to make many layers of information. With this information is very interesting because there are zones, you know, is different, but no, so many zones, so micro zones we are finding in our fields, because normally the farmer see only in the upside of the land. And with this kind of information, we can go through the land, through the soil. And this is very important. Now we make small areas with different electroconductivity. And for example, we make samples in these areas. And to do that, we make very studies with universities and the enterprise to see what is more important, to know it with this data, what can you do it? And it's very important. Like Manuel said, now we put it in the VRT system with the fertilizer. Is possible to apply only when we decide. For example, in the last 2 years, these fields, for example, we don't apply phosphorus in these zones, and there are zones we apply a lot. For potassium, the same, and for the nitrogen, the same. We can put it what you want it, and for example, now we can study the result very fast with the productivity maps. All data are recalled. All jobs we do in the farm, in 2018, we began to have all together, all data and all time it the time, the number of the day, the weather is registered. For example, this is plow, and to put it more herbicide, for example, here, if there are some problem in the future, you can go back to the database, what happened in these days, what's happened, what was the tractor, what is the speed of the application, what are the problem of this application. And because of that, it's important to see in the hands, if there are problems, we can go back and see what is the problem for us. For example, in the seeds, we make different seeders, different number of plants for hectare. Here, for example, is the many tractors we passed in the fields. And to recall the field maps is very important to know where is this. If there are a problem with the RTCAP, the GPS, there are problem in the data, and so on. Is very important for example, to see the compactation of our soils. In the irrigation, perhaps the most important thing, because 30% of our costs is water and energy, and we use a lot of intelligence to irrigation the best way. And we are sensors, meteorological stations, probes, and we are trying to have the more knowledge to use the right water for the right time and for the right plants. And this is very important. Now we passed the platform to know what is the cost, what is the number of liters of water, what is possible reduce the water and the electricity. For example, now we introduce the emission from irrigation. We know what is happening in each hour, what is the grid emission, and we make the data organized. The layer of information is the best to avoid errors, because there are many things you can do, but altogether, like said Manuel, is more important because the information is not so good in one layer, for example, but you are another information. For example, here, the drones. We are using drones all the weeks of in the summer, and we are digital terrain. For example, there are problems here because there are a problem in the soil, and there are a problem with the electroconductivity. But for example, the productivity is not so bad, and compactation, for example, is the cause of something that are happening here. So it's important to make all together. Here is the big problem now, how to manage all this data. And this, we need a little bit more help from the university, from the studies, from people who comes here. Perhaps people from Sparkle can help us because they are making the course, and perhaps they are can help us to do this work. Now we collect 5 million data, 2 million data for years. Oh, it's very difficult to organize. And now our strategy is put it in the platform like Power BI to visualization and Python and R. And now it begins to have a lot of possibility. Communication automatically organize all brands, like Manuel said, is very important. And now analysis software is our goal now. What we're going to do with all this data, we can do right decision, make good decision, like we make now with choose the data of seeding, what fertilizer is best, what water appliance is the better for us. Very, very important, this data to management, because it's possible to make different approach and then record the data, for example, productive maps, and see if our possibility is good or not. So it's very important. I'm help you, you can help me. So many people, we are together, so many people do know very well this kind of problem, and I help in the hand of the project to continue to work. So thank you very much. It's your time, and thank you, and Merry Christmas for all.
Our next speaker is Joannata Pulignani. He is the technical director of the Mackenzie Massey SPA, and one company since 1413-5. The state cover an overall surface of more than 600 hectares in Tuscany and in the area of Chianti Classico. Part of this area, around 100 hectares, are devoted to special vineyards. So he's come to talk us about sustainability in precision viticulture, and let me give you the power. Okay, you can now prove the presentation. Okay.
Okay. Okay. Thanks for the presentation. Thanks and good morning to everybody. Thank you very much, Angela. Okay, we start with our presentation of Marchesi Mazzei. You have well introduced the Marchesi Mazzei as SPA. We are a farm with a very long story in Chianti Classico. This is the area of production of wine. Is called Chianti Classico. Is an DOP, probably one of the most old known in the world. The aim of our farm and our goal is to produce extremely typical wine linked very much to the terroir, to the history. This is our principal goal for our farm. And specifically in the last 20 years, another goal is sustainability and increase the sustainability of the farm, but not only the farm, but also all the society and all the wide area around the farm. And we think that the only way to improve one of the tools is the smart agriculture and the precision farming. And so one of the goal is to start for the sustainability of the soil. We start with precision agriculture using a particular system, an electromagnetic wave system that allow to identify and analyze all the soil of the farming. In specific case of us is vineyards. We have 111 vineyards over the farm. So with this particular system that we have a cooperation with the site of Sang, they allow to analyze the different profile of the soil, 10, 15, 10, 100, and 180. And so after this characterization of the soil, we are able to analyze chemical and physical point. All these data are collected with GPS, and so we have a possibility to georeferencing of the position of the analysis. And so we are able to choose the correct rootstock for Sangiovese, but at the same time we can it allowed to have good decision for the fertilization and for the systemation of the soil. Another aspect for us very, very important to reach our target is to the implementation of the work with the tractor, in particular using monitoring and traceability of the guys, in particular of the work of the guys. And this is possible with telemetry. This is an online system that allow to have a monitor minute by minute of what is doing and what is happening in the fields. In particular, with this traceability system is included agro-planning. This is a very, very interesting way, interesting system to monitoring. And this is important also for traceability of what we are doing, not only for us, but also for our final consumer, for the consumer, because we can distribute the information to everybody for each operation that we done in the field. Note therefore this system, the telemetry, allow to minimize and the distribution of the errors that we can do and the operator can do in the field. Moreover, we have combined to the sprayers the flow meter that allow to understand minute by minute what happened to the sprayer, because the system it has an online measurement of the flow of the water that we distribute in each winery, and so allow us to reduce and to control if are present the error during the working in each vineyards. Moreover, the data provided by the telemetry are displayed in real time, clear to the company, to a remote computer, and are exported to a system, a wide system software called Agros. This is a very important software that collects all the data that we have by precision farming and smart agriculture. This is very important because without this system, it's impossible to understand and to have a synthesis of the data that we have with these particular tools. Another very important aspect for us for quality and for sustainability is that the awareness of the variability is crucial. The variability of the vigor inside the vineyards, but in particular for each parcel of a vineyard. And so it's very, very important to examine the quantity and the quality of vegetation that is present in each part. And so we had a collaboration with Azure Cooperative. This is a company very important in Italy that allowed to work with the GPS and with remote and proximity sensor like satellite and drones and encodes that can identify variability inside the photographed areas. This is important because with this particular world, and we have we analyze the NDI figure of the map of the wineries. We have we processed it into a prescription map. This map is very important because we want to we go to work with a particular system. In particular, we work with variable release machine that work in different situations, low, medium, high vigor. So we can have this. We have the possibility to for the application of the correct dose of nutrition to the soil for each plant. And moreover, we can manage completely separated the high, medium, and low level of vigor for each plant and for each plot. Another for the quality of our farm is also to the monitoring of the production of the grapes inside each wineries. In particular, the aspect of quantity of grape influence the management decision that we aim at preserving the vegetative and productive balance. And so we developed with the CNR and the Biometeorology Institute of Florence a particular model that allowed to us to have a very objective prediction of the yield of the grapes, and so it's possible to obtain this analysis by drones and photo by high resolution, and it was done during at the end of July, beginning of August, with 1 or 2 fly of drones. It's possible to have a response with a particular analysis developed by Biometeorology Institute that give us a report of the potential production of the grapes and the yield for hectares. So we can manage the possibility to reduce the quality and reduce the production for hectare to improve the quality of the grapes. All the data I've told before are collected at the same time, also in the same system called Agros. And so it's possible to have with different layers like a GIS to widespread all the data on the aerophotogrammic display, but also we have the possibility to analyze online the data coming from the telemetry online. At the same time, we have another very interesting development during the last 5-6 years, and in particular, the using cutting-edge technology to obtain high-quality products, safeguarding the environmental impact and maintaining biodiversity. This is obtained by, in particular, against harmful pests like Lobesia botrana and Bactrocera oleae. Lobesia botrana is one of the harmful pests for Sangiovese, in particular for wines in Italy, but also in Tuscany, and for olive oil, Bactrocera oleae. For Lobesia botrana, we have an organic and biological approach with sexual confusion, and so we go to analyze we analyze all the mass trap and the attracts with the pheromones, and after we decide if is a goal to have a biological product. Moreover, for olive tree, we have developed with the spy flies and a Switzerland Society and a CNR of CRA of Florence, in particular Department of Anthropology. We have developed a particular system because we have created with her a particularly an automatic system that capture the insect, harmful insect, Bacteria inside a small box by pheromones, and there are a particular system that recognize the insect, make an elaboration of the data of the number of the insect present and the data of the weather. So we have a prediction of the risk that we have for these pests, and so we are able to organize the spraying and in particular to reduce the number of the treatment and the using of the water. We have also developed a system for defense by wild boar, because it is a very harmful animals for us, in particular in the area of Chianti Classico. And this is a physical defense using the sound wave that are very nice for them, but not for the other animals. This is a particular system that we have, that are developed in particularly in Tuscany. Then another important target for our company is the use, in particular, the forecast model for disease, in particular, particularly mildew, botrytis, and the powdery mildew. They are the principal disease for the grapes for us in Tuscany, particularly in our area. So,
Jonathan, 2 minutes.
2 minutes, only 2 minutes.
Okay. Yeah, sorry.
Okay. I try to be very quickly. Okay. Otherwise, we use this forecast model for the disease to improve our system in defense of the wineries downy mildew and powdery mildew and botrytis. And so this is system allowed to reduce water and pesticide in particular. And so this is the final part of the farm. After the wineries, we arrive to the winery, and so we have also here an integrated system with agros for agronomical for management of agronomical data. In the winery, we have another system that is called created by Parsec that allow to manage all the grapes that are arriving from each parcel and create a separated vinification of each parcel, so to have the best quality and to improve the typicity of the wine that we allowed. Thanks for